Hi, I'm Ben Ames. I'm Senior News Editor with DC Velocity magazine, and we're here in La Quinta, California for the MHI Annual Conference in 2019. Joining me today is Christian Wurll. Thank you for being here.
You're welcome.
Christian is a professor of electrical engineering and automation at the University of Applied Sciences in Karlsruhe, Germany. And he has held executive positions in the industry at companies including Swisslog Automation and KUKA Robotics. So you've had some long experience here with the issues that we're all here to discuss this week. Christian, we were talking before the film started rolling here about some of the trends that we're seeing, companies trying to deal with labor shortages and fast fulfillment demands. The robots are coming, that the technology is developing very quickly, but I think you were saying that you found that not every one of them is really ready for 24/7 use yet.
Yeah, absolutely, Ben. As I explained earlier, so I have implemented many systems and applications in logistics warehouses, but still using the traditional industrial robot arms, which are then basically caged in order to not hurt or damage any people who are running the applications. So there's a new trend coming with all the cheaper robots. We call them collaborative robots. They are certainly designed and developed to run without a safety fence. But that requires that these robots fulfill certain rules and safety precautions. And what we observe, especially in Europe, is that the machine laws we have to fulfill in the European Union are pretty tough to fulfill, because all the forces you can apply to with an, let's say, a collision with a human being, they are pretty low, which means that you have to run these applications at a very, very low speed. And that contradicts then to a throughput. You want to achieve a high throughput, and you can't achieve them running at a very low pace. And that means that that is a hindrance to actually deploy these robots in those numbers all the industry is really looking at.
Right, return on investment, you really need to be able to compare favorably to a human version that might be doing those. And while a robot might be more reliable, they're not going to take a sick day. But if they're running slowly, then the throughput just isn't there.
Exactly. And as you can see on all these typical industry fairs, whether it's the Automate in here in the US or whether it's the Automatica in Germany, you see all kinds of new suppliers popping up. I mean, it's kind of crazy how many new suppliers are showing up at these fairs. But if you really look carefully into these various vendors, then you can still see some differences. Certainly not every robot type is really suited yet to run 24/7 in my mind. They are nice, they look actually well designed, but if you compare them then with the well-known suppliers like Universal Robots or KUKA, then there are huge differences. So really you have to be careful what type of robot you are really selecting. And then certainly you have to run quite some tests, and you really have to see what rules you have to apply in your organization.
Right. So it sounds like that there are a number of challenges, that the organizational restrictions on safety, that the reliability, the speed, and then also that some of the cobots are not actually operating in a fashion that's so collaborative yet, we're saying. Is that right?
Exactly, yeah. And then keep in mind, you don't have to just look at the robot itself, you also have to look at the gripping technology, so also that has to be collaborative. And then certainly even if your robot and your gripper is designed in the sense of not hurting the operator, you still have to watch what kind of workpiece are you actually handling. If the workpiece has sharp edges, you then still have to come up with a solution how you can actually still avoid a collision between the robot and the operator.
Always. Also, the gripping technology is one aspect of having a robot in your warehouse. But from some of your writings, I believe that pallet moving technology for robotics is going to be one of the up-and-coming applications for them. So.
Absolutely. Yeah. So when we installed our systems with the large integrators, whether it's the Swisslogs, the Knapps, the SSI Schäfers, and so forth, I have seen many, let's say, pallet conveyor styles being implemented, miles of conveyors. And in my mind, I think there is a trend coming up with substituting these pallet conveyors by mobile robots. Yeah, certainly you cannot apply mobile robots everywhere, but I think there they are coming as well. I mean, we can see it with the Kiva systems now being Amazon Robotics. They have, let's say, they have been a game changer in industry.
Sure.
Yeah. So and that now can be deployed also to heavier items, yeah, like pallets. And I think they are definitely much more flexible. You don't have to bolt something onto a floor, which allows you to be more creative in your layouts and so forth. So I think they are coming as well.
Interesting. Yeah.
Yeah.
And then as they come along and as that develops faster, perhaps in that pallet area sooner than in each picking area, it seems like one of the enabling technologies to accelerate that might be 5G wireless technology, because really they always have to have a data link to enable them to be able to work, right?
That's true. I mean, we are closely watching what 5G will bring to us. I mean, certainly you have to have the infrastructure first that you can really deploy it, but from what we have heard and what we are looking into it, it feels pretty promising. Yeah? You can connect lots of sensors and actuators to your automation system and start communicating in real time with these devices. And that allows you to actually come up with newer, smarter solutions requiring less cabling, reducing cost in terms of commissioning those systems, and so forth. So that's, for me, definitely an interesting point, and can only invite everyone to look into this technology, because it definitely will change certain things. I mean, if you look, for instance, in mobile robots, you always need the navigation principles and methods, how you can, let's say, maneuver from A to B inside an indoor warehouse, for instance. And the normal approach is using some sort of SLAM technology with interpreting
simultaneous localization and mapping.
Yep. Yeah, exactly. But it all depends on usually a LiDAR sensor acquiring the data. And with the 5G coming up, you actually have an exact position where your object is. Yeah? So you may not even need anymore those sensors, because in the communication protocol you can actually detect where you are. And that means you can more or less simplify your navigation concepts. No need for any map anymore, and so forth. So I think that definitely will change the way we integrate mobile robots.
That would be a different approach. And yet the 5G technology, and correct me if I'm wrong, but it is something that's really not in the control of the vendors or the platform developers. They have to do that in conjunction with the telephony providers. Is that right?
Absolutely. Yeah. I mean, there are some, let's say, approaches also now being discussed in Europe, that, let's say, the OEMs request their own frequencies.
Oh.
Yeah, to be sort of somewhat independent from the telephone suppliers. I think in Europe we just awarded all these contracts recently, but certain, again, frequencies are, let's say, specified for these OEMs, that they can basically be running on their own. To really make sure that their, let's say, processes are not hindered by the rest of the communication.
Yeah, really interesting stuff. Well, great. It sounds like a neat time to be in the industry. The technology is coming along fast, but we should keep an eye wide open on how this space moves in the next couple of years.
Absolutely. Yeah.
Great. Well, thank you very much for joining us, Christian.
Thank you for having me here. Yeah.
Appreciate it.
Yeah.
This has been Ben Ames with DC Velocity in La Quinta, California.